Hi friends, we're going to continue working with equivalent fractions. You've had a lot of practice seeing equivalent fractions, creating equivalent fractions. Hopefully you're really understanding now that an equivalent fraction is just showing the exact same amount with different number of pieces, right? Different number of parts of the whole. One big chunk, two smaller chunks, right? Halves and fourths. So this model would show that 1/2 is the same as 2/4. What I did was I took this half and I multiplied that half into two parts, and I multiplied this half into two parts. And so altogether in the whole, that gave me 4 parts. And I had to give you 2 of the fourths to make it be the same amount as 1/2. We've seen equivalent fractions on number lines. From here to here on the number line is a half. But if I took each of those halves and multiplied that one into three more parts, and I multiplied this half into 3 times as many parts, then I look back at the whole and I say, oh, altogether there's 6 parts, which means I'm working with sixths. And I need to give you not just one of them, I have to give you 3/6 in order to make it equal the same amount as 1/2. And bar models, you worked with bar models as well. 1/2 is the same as 4/8. Let's think about what really happened there. I took the half and I multiplied this half and made it 4 times more pieces. So 1/2 times 4, and the other half got 4 times as many pieces. Altogether, that creates 8 parts. And so I know to call them eighths, and I need to give you 4 of them. Now, you've had this chance to create models and see them, but we're going to take it today and find an algorithm, a procedure that we can use, an equation that will help us create equivalent fractions whenever we need them. And you will see that you will need them a lot. But let's figure out how to do that. 1/2 is the same as 2/4. So there's 1/2, and I'm going to leave some space right here to show the math that's taking place. And over here is where I'll put my equivalent fraction that eventually we create, right? That's a really bad 4, sorry. 2/4. Okay, so let's think about what happened. We said we took each of the halves and we times them by 2. I took that half and made it into 2 parts, and I took that half and times it by 2. So I'm making twice as many pieces in each of the halves. So I multiplied the halves times 2, and I'm getting 4 parts in the whole thing. They're fourths. Well, how many do I have to give you? Well, thankfully, it's quite easy to see. If I have twice as many parts, I have to give you twice as many of them if it's going to come out to be the same amount, right? And so how you would solve this, 2 times 2, the halves, twice as many halves is going to get you fourths. And if I give you twice as many of those fourths, I will give you 2/4, and it will equal the same amount. So this middle part, and actually I like to do that to really see what's going on, but forget from here to here, this is what's happening, right? You're making the pieces twice as many, you're making twice as many pieces. Let's see what that same algorithm looks like for this one. 1/2 is the same as 3/6. We can see that with our eyes, but let's see what's mathematically happening here. I'm going to make these halves. I took each half and made each of them 3 times as many pieces, right? So I have 3 times as many pieces. Now I have 6 pieces or parts. So I have to give you 3 times as many of them. Isn't that convenient? Multiplying the denominator and the numerator by the same number will give you an equivalent fraction. So multiply those by 3. Let's do this last one here. 1/2 is the same as, and remember, I'm going to leave space here to show you the mathematics that's happening every time we've been doing this, is the same as 4/8. So what happened? I took each of the halves and I times them by 4. I made 4 times as many parts in this half and 4 times as many parts in that half. So I multiplied my halves by 4, and I got 8 parts or eighths. And if I'm going to have 4 times as many parts, I got to give you 4 times as many of them, or it's not going to work out. So I have to give you 4 times as many of them. So 1 times 4, 4. Halves, 4 times as many halves gives me eighths. right? They're still denominators, they're still labels. So these are halves and those are eighths. And I get 4/8. So let's try that with a couple of other fractions. How would we do this one? 3/5 is the same as how many 15ths? I don't see a model anywhere. How am I going to figure that out? Well, if I know my multiplication facts, I'm going to probably be able to know how many times more pieces there are. There were 5. How many times more pieces are there? How many times do you have to multiply 5 to get 15? 3. So that's kind of my clue. I now know that fifths, if you make 3 times as many fifths, you're going to end up with 15ths. And if I made 3 times as many pieces, I have to give you 3 times as many of them, and I'll get 6/15ths. That's how that works. Let's do another one. Let's just do 2/4 is the same as how many 12ths? Well, I have to ask myself, fourths, if I times each fourth by what? Or what number, how would I get 12ths? And the answer is 3, right? Fourths, if I make 3 times as many fourths, I'm going to end up with 12. There'll be 12 parts in the whole, right? A lot more pieces. Well, if I have 3 times as many parts or pieces, I have to give you 3 times as many of them. Bam. Right there. So creating equivalent fractions with multiplication, multiplying numerator and denominator by the same number, right like that, will get you a beautiful equivalent fraction. And notice this, when we're multiplying, we're ending up with a lot more pieces, right? You'll have smaller pieces, but there'll be more of them. They have to give you more of the smaller pieces, and this is fewer of the larger piece. So keep that in mind. When I multiply, I'm going to get more parts, more little parts. Keep that in mind. Let's do some practice.